Segment addition postulate, we are still in section 1.5. Now first I want to give you an example and then you can understand better what this postulate says. Here I have a line. We can call this line AB or BC or AC, or all those different combinations that we can call this line. And I've described here that I have points A, B, and C on this line, and the distance between A and B is 5, and the distance between B and C is 10. And now I want you to tell me what the distance AC is. If the distance from here to here is 5 and from here to here it's 10, so what's the distance between A and C? Can you tell me that? Well, you should come up with the answer of 15, right? Because 5 plus 10 more will give you 15. So that would be the distance between AC. And that's what the segment addition postulate says. This is what it says. It says, if B is between A and C, then I can write this statement. I can write that AC, the distance between A and C, will be equal to the distance between A and B plus the distance between B and C, which is what we just did in our heads. We added AB plus the distance BC, and we ended up with 15. That's what the segment addition postulate says. Now notice that when it says that if B is between A and C, it does not mean that B is directly in the middle. Okay? So A can be here, B can be all the way over here, and C at the end. It doesn't mean that B is right in the middle of this segment. It can be anywhere between A and C. Okay? So there's your segment addition postulate. Now we're going to do some examples. Here's an example. It says find the distance between E and F, and the diagram tells us the distance between DF and the distance between DE. So we can write a statement using the segment addition postulate. We can say that we know that the distance DF will equal the distance between DE plus the distance between EF. And then we can substitute the information we have from the diagram. DF, it says in the diagram, is equal to 16, equals DE. DE is given as the distance of 10 plus EF. And now we're looking for EF, so we can solve for EF as any normal equation. And the way to do that is we subtract 10 from each side of the equal sign, okay? We subtract 10 on this side and 10 on this side, and we end up with 16 minus 10 is 6 equals 10 minus 10 is 0, so this cancels out, and I'm left with EF on this side. So this means that EF is equal to 6, and that is the answer to this example. Now, you might be thinking, why do I have to do all of this work? I know that if I have 16 from here to here and there's 10 here, there must be 6 here. And I don't need to write out that whole equation because 10 minus 6, 16 minus 10 is 6. Yes, you're right. But it's important that you write out all the steps because when we start doing demonstrations, you're going to have to do all of these steps. So practice doing this from the beginning so that you won't have problems later on. Okay, now we're going to do another example. Here are 2 more examples. Let's do this one. Find AC. They're asking for the distance between A and C. So let's write our statement using the segment addition postulate, which says that AC will equal AB plus BC. The distance AB plus the distance BC is equal to the distance between A and C. That's what this says. So let's substitute the values that we have. We're looking for AC, so AB, it tells us in the diagram, is 14, plus BC tells us it's 6. So AC is equal to 20. And you're done. And I know you could have done this really quickly without having to do all of this process, but remember, I want you to practice this. For this one, find ST right here. Let's write our statement for this segment. We know that SR, the whole thing, is equal to ST plus TR. Let's substitute the values that we have. SR is 23, so I'm going to write 23 equals. ST is what I'm looking for, so I don't know that yet. Plus TR, I know TR is 15. So if I want to find ST, that means I have to isolate ST, which means I'm going to subtract 15 from each side of the equal sign. So 23 minus 15 is 8. 8 is equal to, and this cancels out to 0 to ST. So ST equals 8. And there you have it. Okay? Now, for the next example, I'm going to give you one using a little bit of algebra. For our next example, we're going to use the segment addition postulate, and we have a little bit of algebra. I have segment AC, CB, AB. I want you to find how much x is. Tell me the distance between AC and tell me the distance between AB. So let's start. This is what you're going to do. I'm going to use the segment addition postulate. I know that AB, which is the long one, AB is equal to AC plus CB. That's what the segment addition postulate says. Now, let's substitute everything that we know about this expression. How much is AB? It tells us that AB is 12. So let's write 12 equals AC. AC has a measure of x. Plus CB. CB has a measure of 2x. Now notice that on this side, I have like terms. X plus 2x, I can add together and make 3x's. And now to solve for x, since we're multiplying 3 times x, we undo this operation by using an inverse operation of multiplication, which is dividing. So we divide this side by 3 and this side by 3. And on this side, this cancels out and I have x equals to 4. And by the symmetrical property of equality, I can rewrite it as x equal to 4. So I found that x is 4. How do I find AC? Well, I know that AC equals x. That's the measure of AC. It's x. So if AC equals x and I found x to be 4, that means AC is 4. Now let's find AB. AB is equal to what? AB, I'm sorry, it should say CB. CB. Okay? CB. So let's scratch this out. Let's look for CB. CB is equal to what? What's the measure of CB? It measures 2x. So I substitute CB is equal to 2 times x. X we already found to be 4. So that means that CB is equal to 8. And we can check. If x is equal to 4, that means if this measure from here to here is 4, and this measure from here to here is 8, then the whole thing should measure 12. And it does. 8 plus 4 is 12. And there you have it. We'll do another example with algebra. Here's one more example using algebra. I have that dt is equal to 60. That means this whole thing from here all the way to t, that measures 60. And it tells me to find x and then find the distance between ds and the distance between st. Now the distance between ds is 2x minus 8, this distance here, and the distance between s and t is 3x minus 12, okay? Whenever you see the values in between the two dots, that's what it measures. So let's use the segment addition postulate to figure this out. I know that dt is equal to ds plus st. I know how much dt is. It is given. So I'm going to substitute it. 60 equals ds. It is also given. It's 2x minus 8. Now don't be confused by this. Let me erase this so that you don't think it's 1 minus 2x. It's 2x minus 8. Let me erase all of this here so that you're not confused. I just wrote it so that you could see it's the distance between the points. But I can see you can be confused thinking it's a 1. So we're back. 2x minus 8, that's the distance between D and S, plus st. St measures 3x minus 12. And now what we do is, on this side of the equal sign, we combine like terms. I have a 2x here, which is a like term with 3x. So that means I can add those two together and I get 5x. And the other like terms I have here are minus 8 and minus 12. Notice I have negative 8 minus 12. Let's do this to the side. Negative 8 minus 12. That's the same thing as negative 8 plus negative 12, which is negative 20. So this is minus 20. Okay, and now if I want to find what x is, I need to isolate this term that has the x on it. So how do we do that? We have to get rid of this 20 that's next to it. So to do that, I have to add 20 to each side of the equal sign, plus 20 plus 20. And what that does is, on this side I get 80 equals 5x, because these two cancel out. And now to find x, since I'm multiplying 5 times x, I can undo that by dividing by 5 on both sides. That cancels out and you get that x is equal to 16. So x equals 16. And there you have the first answer because they asked you for x. So far x is equal to 16. Now they want you to find ds. ds equals 2x minus 8. So now take the x that you found and substitute it for x, and you can solve. 2 times 16 is 32 minus 8, so ds must be 24. Now let's go ahead and find st. For st, it says is equal to 3x minus 12. Take the x that you found, which is 16, and substitute it where you have the x here. And now 3 times 16 is 48 minus 12, and that will give you 36. So st is 36. Now let's use these numbers that we've found and check our diagram. If st is 36 and ds is 24, then I should be able to add these two numbers and get 60. And we do. So this and this is correct, and so is our x. Okay? Now, this is all we're going to do on segment addition postulate for now. I will see you in the next video.